Hello friends, welcome all of you our YouTube learning channel Accurate ASME ISO. In this video, we would understand how to measure a distance on three-coordinate measuring machine with a command by giving plane to plane and by doing the axis alignment. If you like this video, please do not forget to subscribe it, Accurate ASME ISO. Let us take one example to understand very clearly how a distance to be measured. In this picture, there is a one part shown to you. This is a solid body, for example, and there are certain the rods or the taps are equally spaced in a piece circle diameter, and their top surfaces are very flat, and the measurement requirement is this one. It is shown here from the big surface of this bottom to be checked on this surface of the taps. So there are two options in the measurement. Option number one to measure this plane. So this is the first plane, the large circular surface, and then you have to measure the second surface on the tab shown here. So on each tab, measure 1 point, and that is, I would tell you, here I measure, and that plane is 4, and this bottom plane is plane number 3. And suppose the option 2, I want to find the plane to be measured just on one tab. Assume all tabs are good and consistent in the height from the bottom surface, and also the accuracy are well considerable. If I make the measurement here, it would be okay. So these are the two options I have for the measurement on three-coordinate measuring machine by measuring a bottom plane and plane to plane distance, plane bottom and the tab plane, or a single tab plane. Now, what are the results after measurement? And before showing the results to you, please find it here. When the bottom plane is measured, the form deviation is around 5.9 micron. Approximately, with the number of points taken are good enough, and the deviation is also fine. When the tab plane on the top, measuring points on every tab, that plane number 4 measures its form 2.1 micron. So it is better than the bottom plane. And the plane which is measured on a single tab, because of the small plane, which is an excellent form, that is less than a 1 micron. So this is just idea to understand how smooth or rough or the finish of the part and the plane is. Now, after measurement of all three planes, plane 3, plane 4 and plane 5, the requirement is to find the height of the tab plane from the bottom plane. And I made it repeated for 3 times. Option number 1 is calling a distance in the software as a direct distance. Then with this methodology of the distance measurement, you would see here from the bottom plane to the tab plane, the 6 tab plane, the measurement result shown here is 8.0001, 7.9999, and the third reading also repeated. So the repeatability between 3 readings 0.002. So it is an excellent repeatability, not even half micron. Then if I make the distance between plane 3 and only a plane of tab 1, then the reading says 8.0162. So 16.2 micron is the error to the 8 millimeter of the nominal dimension. And also if you see the repeatability is also increased from the case of condition number 1, and it is now 1.1 micron. Suppose in the condition number 2, if I did not ask the direct distance between planes, then what I did, I measured a plane, the bottom plane, and I aligned it. That means the truing in general or the common language if I speak. So after the alignment of that plane and creating an axis, in that direction of the axis, when I do the measurement from plane 3 to plane 4, but I call the distance in the z direction, I would say this distance is coordinate distance than the direct distance. So here you can see the first is repeated well. Also, when I measured the coordinate distance from plane 3 to plane 5, it is a lot improved from the first condition, 7.9971, 9973, and 9978. So repeatability, you can say it is excellently improved, and also the dimensions, you can see it is more appreciated than making a distance directly by measuring plane to plane. So what we take a lesson from this exercise, when on the CMM you want to do the measurement by plane to plane geometry, don't go and ask direct distance. It is always better if you have alignment and if you find a coordinate distance in particular direction. So this is the takeaway from this exercise. On the same time, I would like to inform you here how the measurement is done on 3-coordinate measuring machine. Suppose you have measured this plane as like the bottom plane, and suppose this is a plane which is measured by putting points on all tabs. So center of that, almost the area covered, becomes a centroid. This is a centroid of the plane. And when you call the distance between this plane to this plane, what happens, the distance is calculated in the algorithm or in the mathematics of the software, CMM software. From that centroid, a perpendicular or the shortest distance, I repeat, perpendicular or shortest distance is measured. Now, what happens when the plane, like a tab plane, is away? The tab plane is away from the main plane. In that case, what happens? Also, you will get the error. The measurement here and measurement here is different. So what is this error? This error is because if the planes are not parallel, then such kind of the errors occur. Now here you can see, if suppose here is a one plane, here is a one plane, or here is a one plane, or on the same plane, if you only taken this area, then centroid become here, only this much area, then centroid is here, and again the same thing is. But being this bottom plane and the top plane are perfect parallel, then absolutely there would not be any problem when you call the distance from this plane to this plane. Now, the point of conclusion here is, suppose the planes are not parallel, not good in parallelism, and on the same time, the planes are at offset. So this is the main plane you measured. The second plane is not parallel on the same time. It is a far at certain distance. At that time, what happens now? The distance becomes like this. When this is offsetted, at that time, the plane you measured as a bottom, that would be in an infinite length, and at that point a perpendicular distance is formed. So the lesson here is, when you measure the distance of the planes, and if the planes are not one and the above, and also they are not parallel, and also they are at offset distance, there are chances of inaccuracies in the measurement. And that is all because of your mathematical calculations. So what I recommend here, I recommend you do the reference measurement planes with large number of points, so that maximum orientation is consistent and your repeatability of the measurement will becomes very, very easy. Then in that case, you can see here, if the planes are parallel perfect, if they are parallel perfect but at offset distance, still then you would get the better result. If this plane is here or here, it doesn't make any difference, you will get the better distance. And if it is not, then surely it is a problem. If you like this video, please subscribe Accurate ASME ISO on YouTube channel. Please like it and share to others. Thank you very much. Take care. Bye. See you in next video.